Check it out, geometers. Today we are starting 1.2 and we're going to do like the Greeks do, which is constructions using straight edges and compasses, which is pretty cool. Bless you. So, 1.2. You guys may have some of this. You've already done the explore stuff where we played around with those circles with the protractors. Okay, in 1.2, we are looking at basic constructions. Now, every construction that we do, we will physically do on paper with a straight edge and a compass. With the understanding that Desmos, if you guys all have computers that are operational and you want to learn how to use a little bit of technology, Desmos, the fantastic graphing calculator that your teachers have probably used, also has a geometry function where we can draw segments and angles and all of those things. Okay, by the end of today or the end of 1.2, you guys are going to be able to construct several different things like specific constructions that we'll keep learning throughout the year, but you're also going to be able to identify and work with congruent angles and segments. So our first topic before we start playing with those compass is going to be the definition and what it means to be congruent. So we're going to define congruent. Now, mathematicians in general don't like to write a lot. I especially don't like to write a lot, but there are a lot of shorthands that are accepted. Congruent, we'll put the actual shorthand symbol that we will always use right inside of those parentheses here in a minute, but you guys have seen congruent figures before. What does congruent mean? So same size for sure. Like the sides that you're referring to, that would give us the size of something, right? So if two squares are congruent, they have the exact same side length. Any other parts that you guarantee are going to be the same? The angles, same size and shape. Now, if we're just talking about an angle, if I say two angles are congruent, they're the same angle. They have the same measure is what that'll actually mean. Okay, because we have shorthands, the fact that they're the same length and measure says we get an equal sign with it, and then that's the same size. That's what this means. Same shape, we'll see later chapter that it means their shapes are similar, so all triangles are triangles, right? They're kind of generally the same shape. We use a tilde to represent this. Equal with a tilde above it is the symbol for congruent. Yep, a tilde. It is shift beside 1 on your calculator. Anyway, to mark things as congruent, you've already seen me do this. To indicate, we're going to draw a little picture here. Just a little one. I'm going to draw two copies of the same thing, but we'll name our points differently. So I'm going to draw this lovely angle. You don't have to draw this exact same angle, but I need an angle. And then you're going to try your best to draw an identical angle right next to it. And gosh, I'm good at copying and just drawing the exact same thing freehand. Phenomenal. All right. Two angles that should be believably close. Everybody got it? All right, let's name the first one A and D. So starting at the top, we'll go alpha, and then November, and then delta down here. And then this one, we'll go ahead and name Romeo on the top, Echo at the vertex, and W, whiskey, down here. That's for you, Toledo. Okay, looking at this. If I want to put some ticks on this, like let's say I'm comparing these two angles, and I say that this gets a tick and this gets a tick. What does that indicate about the length of NA and ER? They're the same. Okay, are they also both segments? So they're the same size, but they're also the same shape. We just determined that those segments are what? Congruent. So check it out. We are going to physically write segment AN, and it's the physical object, so we put the bar above it, is congruent to segment ER. Now, we're going to learn in shorthand right now. You would never put segment is equal to a segment. You wouldn't do that because we're not talking about the physical object as soon as you say equal. How many of you guys have seen this symbol in math? It's a double arrow like this.
I have.
Who can tell me what it means?
It means like goes into.
Kind of. Possibly.
Like
Implies. And it just means logically it leads us to the following. If two segments are congruent, same shape, same size, is their length the same?
Yes.
Yeah, like that's obvious, but the notation does matter. We would say AN is congruent to ER, which implies that the measure of AN, without the bar above it, is the same as the measure of ER. And it's tedious, and I get that it's kind of redundant, but if we don't do this, we get into all sorts of problems when we're trying to logically build arguments. Okay, is it possible, I'm not going to write this one down except for the ticks, is it possible that ND and EW were also the same size?
Absolutely.
Could they be different than AN though?
Yes.
So if that had happened, if I put a tick and a tick, can I really tell which one's the same as which one?
No.
Because now it looks like they're all four the same. What if I only wanted the bottom ones to be the same?
Get rid of the other tick.
You could get rid of the other tick, which could be a cumbersome thing to do if you have a bunch of ticks. Or, Camille, say it louder. Could we use 2 ticks for the second one? And 3 ticks for the third. And then some books will use like 4 ticks. I just switched to like orthodox cross style so that I don't have to count them.
What's like a T?
So I would do, if I got to like 4, instead of going 1, 2, 3, 4, I would do up to 3 with the ticks, and then I would start doing something like this. Orthodox
Why
cross.
is it like that?
It's a me thing. Nobody else does that
Well,
that
no,
I've seen.
Just like the
I have no idea. I'm not orthodox. Okay. Is it possible that this measure of this angle is the same as the measure of this angle? So notice I'm being very specific. The measure of the angles could be equal. If the measures are equal, then the angles must have been not equal. We don't say the angles are equal. We use a different word. Congruent. So check it out. We can also say, and this is that case where if it's clear what we're looking at, we can get by with it. I could name this angle A and D, Alpha November Delta. If I was given you, or you were given this picture and I just write angle N, can you tell which angle I'm talking about?
No.
Yes.
Maybe.
Would you assume it's this angle?
Yes.
Okay, we're good. I will use this convention. If there's no like concern for being wrong, I will just do it like this. Angle N was congruent to what?
Angle E.
How would we mark it on our picture?
Tally.
So tally won't work. Tallies are for segments. We will use a different shape. We use an arc, which is just a part of a circle. So if I wanted this angle to be the same as this angle, they would both get 1 arc. If I had another pair of angles, thoughts on what I might do? I might do 2. Same thing, if we ever need it, I might eventually get to doing something that looks like this if we have a bunch of them, so I don't have to count how many little arcs are on it. Okay, if these angles are congruent, it implies their whats are equal.
Lengths.
Angles don't have length.
Oh, degrees.
Good. The measure of the angles are equal. Okay, here's what I want you to do. Have a wonderful afternoon.
Oh.
Yeah, time flies, right? Okay, on your way out, will you please put those compass back with the ones that tried to adjust themselves? In the left drawer, don't put them back in the box, put them in the other one. Tomorrow, we will be doing a bunch of Greek math. Oh, we could learn the Greek alphabet.
How about we
I like Greek yogurt. Or not.
We can't eat in class, Ray.
I didn't eat breakfast.
Chobani!